Alright, this video is part 2 of a lesson on polynomials. In this video we will continue to take polynomials and we will factor them and find all the zeros. Okay, so I'm going to use this function right here and the graph to answer these questions. So they want us to factor this and find zeros. So let's start by looking at the graph and see what zeros we can see. Okay, it looks like probably -3 is a 0. It looks like -1 might be a 0. There's something going on in there, but that could be irrational, so I don't know. But it looks like probably +1 is a 0. Now some of these that look like they might be zeros, maybe they're not. So we won't really know until we use our synthetic division. So let's get started. Let's do some synthetic division and see what we have. Let's start with the -3. Okay, just kind of working from left to right. So let's grab some coefficients off of here. You know what, maybe I'll do my synthetic up here. So okay, so the coefficients are 2, 5, -5, another -5, and +3. Okay, so I'll bring my 2 down, multiply, I get -6. Add -1, multiply, +3. Add -2, multiply, +6. Add +1, multiply -3, add 0. So I've got this. Now I believe I could do grouping right now because I'm seeing the pattern 2 1 2 1. So I'm betting grouping would work, but you know what, I have possible zeros right in front of me, so I'm just going to keep going the way I'm doing it. So to use the next 0, I can just pick up where I left off. So I've got the -1, so I'm just going to put my -1 right here and keep going. So I'll just draw another line here and another box here. Okay, so I bring down the 2. Multiply, I get -2. Add -3. Multiply, +3. Add 1. Multiply -1, add, I get 0. Now once I get down to 3 terms, that's going to be quadratic, so I'll just factor that or use the quadratic formula. So if I put the variables back in, I've got 2x squared minus 3x plus 1. Okay, and the factor that comes from this 0 would be x plus 1, and the factor that comes from this 0 would be x plus 3. So far we have this, but we can probably factor this further. So let's give that a try. So if I go to factor this, I'm looking at 2x squared, and I'm thinking, well, that can only factor as 2x times x. And then I'm looking at 1. 1 can only factor as 1 times 1. And then I'm thinking, inner plus outer equals middle. Inner, I have 1x. Outer, I have 2x. I'm trying to get a middle of -3x. Is there a way that I can get -3x out of 1x and 2x if I choose the signs right? Sure, if both of these are negative, that'll make -3x. That means both of these would have to be negative. Will that give me a +1? Yes, a negative times a negative is a positive. So that means this is now factored correctly, and I'm just going to bring down my x plus 1 and my x plus 3. Okay, so this is now factored completely. So I'm just going to go ahead and copy and paste this. onto the answer line. Okay, so we're supposed to write h of x in factored form, and there it is. But we're also supposed to find all the zeros, and there they are. From the x plus 3, I remember that was my -3, and the x plus 1 came from -1. And from the 2x minus 1, if I set 2x minus 1 equal to 0, I could add 1 to both sides. That would give me 2x equals 1. I could divide by 2. That's going to give me x equals 1/2. So I've got 1/2. And then from the x minus 1, that's going to just give me 1. And you know, looking at the graph, we almost could have guessed that this one is 1/2 because it seemed to be right in the middle, but why take chances? So there we have all of our zeros, and here is the factor form. So that's it for problem number 3. Okay, so let's take a look at problem number 4. We are supposed to write a polynomial function for the graph shown. Consider zeros and end behavior and leave your answer in factored form. Okay. Alright, let's start by identifying the zeros that we can see. We see -3 is a 0, and we've got 4 is a 0, and 8 is a 0. Those are our 3 zeros. Okay, so looking at that, let's turn those zeros into factors. So a 0 of -3 is going to give us a factor of x plus 3. Okay, a 0 of +4 would come from a factor of x minus 4. And a 0 of 8 would come from a factor of x minus 8. Okay, so we'll have these factors. However, we need to pay attention to what's happening at each one of these zeros on the graph, because we learned that the graph tells us something depending on if we have a bounce like this, or if the graph just goes right through the 0 like this, or if we have an inflection like this. And what we learned is when you have a bounce at a 0, that means that that was a double root. So that factor, there's really 2 of them, so that's going to be squared. We learned that when the graph passes straight through a 0 like this, then that's just a single root, so we're not going to put any extra exponents on it. But we learned that when we have an inflection like this, where it sort of flattens out and curves the other way, that indicates a triple root. So this will be a triple factor. Okay? So the other thing we need to watch out for is with the end behavior. Is this the end behavior of a positive leading coefficient or a negative leading coefficient? You know, and think of how a parabola behaves. This has the same end behavior as a parabola, okay, with both ends going up. But if we had a parabola with both arms going up, would this be a positive leading coefficient or a negative leading coefficient? Yeah, this would be positive when both arms are going up, which means that we don't need to stick a negative sign on here. If these arms were pointing down, we'd have to put a negative in front, but we don't. Alright, so we're allowed to leave this in factored form, thank goodness, because that would be an ugly one to multiply out. So we can just put this on the answer line and we're done. F of x equals kabam. Or did they give us a letter? No. So that's the answer for number 4. Does it really go straight from 4 to 6? Let me look around. Alright, take a look at number 5. For this one, we're going the other way. We're given the factored form, and using our knowledge, we're supposed to sketch a function that would match this. So the first thing we will look at are the zeros. So a factor of x minus 1 would come from a 0 of positive 1. Okay, a factor of x plus 3 would come from a 0 of negative 3. Basically, if we set, x minus 1 equal to 0 and solved, and if we set x plus 3 equal to 0 and solved, we would get 1 and negative 3. So we know we will have those zeros. So 1 and negative 3. So there will be a 0 here at 1 and a 0 here at negative 3. Now be careful. The multiplicity tells us something. Okay, looking at the 1, we see that it is squared. That means this is a double root, and we have learned that that will be a bounce in the graph. Okay, so as the graph approaches the 0 of 1, and I'm going to temporarily write the word next to it, this is going to be a bounce. Alright, I'll erase that later. On the other hand, this negative 3 came from a factor that's cubed. Alright, this is a triple root. And we learned that a triple root corresponds to an inflection. Okay, that's where the graph sort of flattens out and curves back the other way, an inflection. Alright, obviously a bounce is kind of like that. So there should be an inflection happening at the negative 3. So let's make a note of that. Inflection. Alright, so now let's talk about the degree. Well, there's 2 of these and 3 of these. So that means that the degree is 5. Okay, this is degree 5. So the importance of that is we're looking at an odd degree. Now, odd degree functions have a similar, well, the same end behavior as a cubic function, which is also odd. And cubic functions typically look like this. Alright, well, they look like this when they're positive, leading coefficient, and they look like this when they have a negative leading coefficient. Okay, so a degree 5 graph does not look like this, but it has the same end behavior as this. Okay, so what about the leading coefficient? See that minus sign in the front? So that tells us that we really need to be looking at this version of the graph. Okay, the negative leading coefficient version. Now, a true degree 5 is going to have an extra bend in it. So just to be clear, a true degree 5 graph is going to look more like this. Okay, that's degree 3 so far. So degree 5 is actually going to have an extra bend in it. But that's not so important. And this is, again, is the negative version, sort of an upside down end shape. The point is, as we draw the graph, if we know that this is the general feel of it and behavior wise, we'll start high and end low. Okay, so we need to make sure that we start up high and follow these instructions and end up low. So let's give it a shot. Okay, so we're going to start up high, but when we get to this 0, we're going to do an inflection, and then when we get to this one, we're going to end in a bounce and hopefully end up low. So coming from up here, okay, so I'm coming down, and I know I've got to do an inflection, so I'm going to sort of level out here and then curve the other way. Alright, now I'm going to curve back around in time to do a bounce at that 0. And then, sure enough, I end low. Okay, so just like we wanted, okay, we wanted to start high and end low. We did that. But also we needed to do an inflection here and a bounce here, and we did that as well. And it's important that we didn't create any other zeros. We didn't cross the x-axis anywhere other than the 2 zeros that we had. So this would be a good graph for this. Alright, and that is a good length for this video. So we're going to go ahead and stop this here. I hope it's being helpful so far. I hope you're not copying off of me. I hope that you're learning from me and then you're going back and trying to do the problems by yourself.
Don't copy off Daddy.
Thank you, sweetie. You're the best.